Hey guys, so I noticed that some of you were having some issues with the task, so I decided to just record this video so that you guys will be able to have a little bit of guidance with it. So just starting from question 1, it's again it's important for you guys to go back and look at your notes that we made on functions and make sure that you understand all the functions first before attempting this task. Please just go back and make sure you understand all the functions, but I'll give you some guidance on it. They gave us 2 functions, and first I just wanted to analyze the functions. This first function here is obviously a parabola. If you've forgotten, it means it's either this shape or this shape. Okay, and then this function is obviously what is this, exponential, because you can see it has x as an exponent, which means it has an asymptote. Okay, then it says sketch the functions. Please can you go and look at your notes. The notes tell you step by step how to sketch the functions. To sketch a parabola, if I'm not mistaken, there were 4 steps. Okay, and an exponential function had steps as well, so please just go and have just go and have a look at that. They want you to sketch them on the same set of axes as well, and you guys have an addendum as well to show you how to do it. Range, okay, remember what range is. Range means the range of f, and a range means all the x. So in other words, they're asking how far up and how far down does the function stretch. What is its maximum point and what is its minimum point? Okay, so you need to look. For example, if I had a function that looked like, if my function for f, and I'm not saying what it looks like, but if it looked like this, then you can see it goes up to infinity at the top, and the lowest point will be whatever the turning point is. Remember I said to you guys, the turning point is the same as the y-intercept. So that would be the lowest point if it's that shape. However, if it is a sad face function, so if it's a negative, if the a value is negative, then you see it goes down to negative infinity and it ends at the y value of the turning point. Okay, that would be the y value of the turning point. Again, which is also the y-intercept. Okay. Domain is how far left it stretches and how far right it stretches. Okay, f again is a parabola, so ask yourself, how far left does it go and how far right does this graph go? Okay, range of g of x, same thing. Range is the y values. Now, because this one is it's an exponential function, which means it has an asymptote. It means there is a line that the function cannot be equal to. Okay, it can either look like this or whatever. It can even be below, right? So what you need to know is, does it go up to positive infinity or does it go down to negative infinity? Sorry for drawing on the question. Okay, and at what point, remember I said to you, I explained an exponential function as having either a floor or a ceiling. So whether the asymptote is a floor or a ceiling, you need to determine by looking at the value of a here. We had said that for an asymptote, for an exponential function, the equation was g of x is equal to a times b to the power of x plus q. Remember? And we said if a was positive, then it would be above. And if a was negative, then it would be below. Below and above and below what? The asymptote. So look at your a value here. What is it for this function here? It's obviously positive. Can you see? Because there's no negative in front. If there's no negative, it tells you that it's obviously positive. Okay. So take that into account, decide if it's above or below, and then decide whether your asymptote is a floor or a ceiling. If it's a floor, the range will be from the floor to infinity. If the asymptote is a ceiling, then the range will be from negative infinity up to the roof. Now it's important to realize, is the asymptote or the value of, let's say our asymptote here was y is equal to 2. Is the value of the asymptote included in the range or not? In other words, can my function be equal to the asymptote or not? By definition, an asymptote means a line. It's like an imaginary line that the graph cannot be equal to. Okay, it cannot touch. Okay, it can get as close to, in fact, we describe it as being infinitely approaching the asymptote, but it never equals that. Every time you think it's gonna touch, it just gets a little bit closer but doesn't touch. Okay, so yeah. Okay, and then anyway, so yeah, I hope that helps. Okay, then describe the transformation of of f. Okay, so my tip on this one would be to expand this out and then see what happens. See how f of x changes. So, and then expand this out and then compare f of x and g of x to each other. Okay, remember how I said that the c value is the y-intercept, right? So now I'm just drawing everywhere, but I'll erase this. Remember how I said the c value is your y-intercept. So if your c value, let's say, is -3, then that means your y value is -3. If I now change it and I make my y value 1, oh, sorry about that. Okay, I changed this number, but it also tells me that I shifted the graph upwards. So while this number represents the y-intercept, it also represents a vertical shift. So I want you to take that into account. Expand out h of x, so you're going to FOIL, ne? And then you're going to look at the c value and see how it's different from the... You're going to look at the c value of... Sorry, it wasn't g, it was h. You're going to look for the c value of h of x and compare it to the c value of f of x. And remember I said to you the c value represents what? Vertical shift. Okay, cool. That's that. Question 2. Says determine... Okay, so they give us in the below diagram, the graph of g of x is equal to -2 to the power of x plus 8. What kind of function is it? I did mention above what kind of... Hello?
Good day, Mr. Mafuso.
It's Miss.
Mr. Mafuso, sorry, ma'am. Mr. Tano, you're speaking to Stenat. I'm calling you from my budget, ma'am, on behalf of my way. How are you doing today?
Not interested. Okay. Anyway, so... Sorry about that. In the below diagram, the graph of g of x is -2. So this is an exponential function, just like g of x above. Anyway, but it looks slightly different. Now, remember I told you that if the a value is negative, it tells me that the function is going to be below the asymptote. And even if you look at the diagram, you can see there, the asymptote is here. The function is below. Determine the coordinates of B. What is B? Remember I said to you guys, and I compared this, if you're a doctor. I said to you, if you are a doctor, Annie, you, before giving somebody medicine to fix a problem that they have, you need to figure out what the problem is. You can't just, they come and they be like, doctor, my stomach hurts. And you're like, okay, here is, oh, you need to have an appendectomy. And you don't know, you just heard one thing and now you already deciding what the treatment is going to be. No, you can't fix a problem without knowing what the problem is. So the same way, you can't determine the coordinates of a point without knowing what that point is. You need to diagnose, you need to classify that point. What is it? What is that coordinate? If you look at B here, it's cutting into the x-axis, right? Which makes it an x-intercept. How do you find an x-intercept? Make y equal to 0 and then you solve. Determine the coordinate of A. What is A? Okay. What is it? It's cutting through the y-axis. So it is a y-intercept. How do you find a y-intercept? Make x equal to 0. Okay. If g of x is reflected about the x-axis to form a new function, h of x, determine the equation of... Okay, I don't think I explained this to you guys, but let me tell you. G of x is reflected about the x-axis. Okay. Here's the x-axis, ne? No, I did explain this to you, I remember. Let's say I had a point over here. And my point, I'm just making an example. My point is -5 and 3. It's just an example, ne? And I want to reflect it about the x-axis, which means I'm using the x-axis, this as a mirror. I'm going to take the point and I'm going to plot it exactly this distance on the other side of the x-axis. So two things are happening. Number one, the x value stays the same. And number 2, the y value becomes the opposite what? Sign. Okay, so because it was negative, the x value is -5, and we're staying on the same x line, you understand? It's still going to be -5 here, right? But the y value, which was 3, I went 3 units down, isn't it? I said the y value was 3, which means this coordinate lines up with the y value 3. If I'm going 3 units down and I'm reflecting, that means I need to go another 3 units down. So I'm going to be at -3. This is going to line up with y is -3. So do you see that when we are reflecting about the x-axis, the x value stays the same and the y value becomes the opposite sign? That's all. And the opposite is true. If I was reflecting this point about the y-axis, now if I was using the y-axis as a mirror, the y value would stay the same because I'm going horizontally. My y value is still going to be 3. But my x value would go from being -5 to being 5. Any? I hope that makes sense to you guys. I hope it makes sense. So when we are reflecting about the x-axis, the y value changes sign. When we're reflecting about the y-axis, the x value changes sign and the y value stays exactly the same. So now we're reflecting about the x-axis. That means the y value changes sign. So what you need to know is that since h of x is a translation of g of x, you're going to say h of x is equal to negative g of x. Why am I saying negative g of x? It doesn't g of x represent y? Yes, it represents y of the function of g of x, right? So you say that, and then you can substitute the equation g of x. You're going to say negative, substitute it in, multiply the negative out, and it's going to give you the equation for h of x. Are we together? Range of g of x we've been through. Is g of x increasing or decreasing? Please, again, I urge you to go through the notes on exponential functions. We spoke about increasing and decreasing functions as it pertains to exponential functions. And what is going to tell you if it's increasing or decreasing, I'll just give you a clue, is the value of b. I'm giving you a clue, but we did speak about it. Okay. Moving on swiftly with question 3. A hyperbola h of x has the following characteristics. It has an x-intercept of h, or the x-intercept of h is 2 and 0. The range is -3 to infinity. To 3. Or 3 is to infinity. Okay. Okay, that's an interesting way to write it. Okay, and then the equation of the vertical asymptote is x is equal to 0. Okay, so remember we had said that there were 2 functions that we dealt with that had asymptotes. The first one was a hyperbola, and I told you that a hyperbola has got 2 asymptotes, ne? 2 asymptotes, but we only really ever, now in grade 10, we're only going to see one of the asymptotes. Okay, which is the horizontal asymptote, and we'll see that one moving up and down. But there is also an asymptote for hyperbola that is vertical, and it's at x equals to 0. X equal to 0 is the equation of the y-axis, please. The y-axis equation is x equal to 0. So this is the vertical asymptote. Even though we don't draw it in grade 10, we're not going to draw a vertical asymptote, but we should know that the hyperbola has got a vertical asymptote at x equals 0. In other words, the y-axis acts as a vertical asymptote for a hyperbolic function. Okay, then obviously we have this one, which we can read off of the equation. Right. Determine the equation of h. Okay, remember that the standard equation for hyperbola is f. Okay, let's use h now because that's what they gave us. H of x is equal to a over x plus q. Okay, what does a tell us? The shape. A tells us what? The shape. So if it's positive, it's going to be in quadrant 1 and 3. Mind you, the quadrants are this 1, 2, 3, and 4. Okay. So if it's positive, it'll be in quadrants 1 and 3, of which you can see the function exists in quadrants 1 and 3. And if it's negative, it'll be in quadrants 2 and 4. So we know that the only thing we know for sure right now is that a is positive. We have an x-intercept at 2 and 0. Okay, x-intercept is when y is equal to 0. Okay. And we also know that the function goes from negative infinity until 3. Uh-oh. I think they made an error on this one. Yeah, no, they made an error. Okay, just please change that on your... Yeah, it's supposed to go... The range is supposed to be until 2 here. This and this are supposed to be 2, ne? Okay. Anyway, but so that means... Because we can see here the asymptote is 2. Yabo? You can see here that the asymptote is 2. So remember, A tells us the shape. So this one over here tells us about shape. And then Q tells us the horizontal asymptote. Oh, so difficult to write, so tiny. Anyway, so Q tells us the horizontal asymptote. And since we can see the horizontal asymptote is 2, we know that it's going to be plus 2. So we're going to have h of x is equal to a over x plus 2. Remember, a is a number. It represents a number. And I need to solve for that number. Right. So if I was... Can you see that this equation has got 3 variables? Here it has x, it has y, and it has a. And I need to solve for a. So doesn't that make sense that if I had an x and a y to substitute here, then I would only have one unknown. The only reason I can't solve for a right now is because there are 3 unknowns. 1, 2, 3. It's x, y, and a. But because I'm working on a Cartesian plane and my Cartesian plane has got 2 dimensions, x and y, it means I could potentially have an x and y value, or coordinates in other words, that I can substitute in this equation and solve for the 3rd variable. You understand? We dealt with the q now because we're able to see that the asymptote is 2 there. So now we can substitute a coordinate. Is there a coordinate on here that exists on the hyperbola? Isn't it now we're trying to find the equation of the hyperbola. So is there a coordinate on the hyperbola? They gave us an x-intercept of 2 and 0. Oh, my bad. Oh, my goodness. No. Which question are we on right now? Oh, sorry, guys. Now I have to... They were not talking about... This and this have nothing to do with each other. This is a different question. What an idiot. Okay, let's try this again. Okay, the asymptote is actually 2. Because they're telling us the range... Sorry, not 2, it's 3. It's 3. Because they're telling us that the graph goes from negative infinity to 3. Now, the round bracket here indicates that the 3 value is excluded. Okay, the round bracket means excluded. In other words, goes close to 3, but not equal to 3. It can never be 3. Okay, so what does it tell us? It's excluded from negative infinity to 3, but excluding 3. And it then goes from 3, not from 3 exactly, just above 3 to positive infinity, which means it's everything except for 3. Does that make sense? So that tells me that 3 is an asymptote. Yay! Oh, that tells me that 3 is an asymptote. Sorry, guys. Yeah, this video is going from bad to worse. Anyway, same thing applies. I needed to find the a value, so I needed to substitute an x and y, and they happen to give me this coordinate here, which was 2 and 0. So I can substitute that in. I can say y is 0 and x is 2, and then I can solve for a. Okay, take the 3 over first, then multiply by the 2, and then you're going to get your a value, and then you can put your a value there. Are we together? Right. Whew. Okay, now let's go on to question 3.2. I'm going to erase this now. Okay. Oh. Next thing says, in the diagram, the graphs of f of x is equal to ax squared plus q and g of x is equal to a over x plus b are shown. The graphs intersect at the point 1 and 3. Write down the coordinates of the turning points of f. Please, we have already discussed this. You guys should know how to do this already. How to find the turning... Oh my goodness. How to find the turning points. How do you find the turning points of a graph? In the previous question, I explained that a turning point is the same for hyperbola in grade 10. The turning point is the same as the y-intercept. Okay, So they're asking for the turning point, but actually they're asking for the y-intercept. How do we find a y-intercept? Make x equal to 0. Or actually it's on the graph. No, sorry, we don't have the equation of f of x, so we're not gonna, you understand, we're not going to make x equal to 0. We just look at the thing, the y-intercept. Can you see the y-intercept? Can you see the turning points? Yes. So just write the coordinate. It even says write, it doesn't say calculate. So determine the equation of the horizontal asymptote of g of x. It's, again, you can see it. An equation has an equals inside, please guys. So you're going to write, is it y equals or is it x equals? Okay. Keeping in mind that it's a horizontal asymptote. Okay, and then determine the equation of the axis of symmetry of g of x that has a positive gradient. Okay. Remember that, and okay, so the mother function for hyperbola, we had our axes over there. Wait, let me actually make those lines a bit thicker. Now, how do you do that? Okay. I don't know if that worked at all. But anyway, so the mother function looks like this. And we said that it had two axes of symmetry, which was one. Oh, that was terrible. I removed my screen protector, so now the pen is like slipping around on the screen. Okay, and the one was y is equal to x, positive x, and the other one was y is equal to negative x. Those were the equations of the axis of symmetry. Remember that axes of symmetry are straight lines, so a straight line has the general formula y is equal to mx plus c. Okay, so this equation then tells us that the gradient is 1 and the c value is 0. Okay, but that is implied. You guys should understand that. Okay, this one then tells us that the other one tells us that m is -1, the gradient is -1, and again the y value is c, and it makes sense because they cut through the graph at the origin. So now remember, c is y-intercept. So now if you now compare this mother function with this function that they gave us, can you see that the y-intercept of the point of of the axis of symmetry will be at 2. The gradients are going to stay the same. It's still going to be y is equal to x, but now there's a different y-intercept, and it's going to be y is equal to -x, and there's a different, it's not 0 like it was in the mother function. It's whatever you see there on the function. Okay, right, and then determine the equation of f of x. Determine the equation of f of x. F of x is the parabola. Okay, so similar to what I did in question 3, but I want you guys to just use your noggins a bit. Then the last and final question says, given f of x is 4 over x plus 2 and g of x is x plus q, f of x and g of x intercept at -2 and 0, which means that -2 and 0 here acts as something called the point of intersection, which means the two graphs cut into each other at that point. Okay. Write the equation of the asymptotes of f and g. Okay, super easy. It's two asymptotes. The horizontal one is y equal whatever. The vertical one is always x equals. It was even in the previous question. In the previous question they gave us, and I did explain already, so you should know. The x-intercept of f of x, how do we find an x-intercept? I'm not even going to tell you because I've said it already a lot of times. Determine the equation of g of x. The only thing that we need for g of x is what? The q value. Remember I said to you that look at this equation for g of x. We have three unknowns, g of x, which is y, we have x, which is x, obviously, and then we have q. Two of them I could potentially have somewhere on the graph. If I have a coordinate that lies on g of x, I can substitute the x value and the y value here and solve for q. Okay, I hope it makes sense. Right, next. Sketch the graphs of f of x and g of x. Please, we've done a lot of sketching. Calculate the values of x for which f of x is equal to g of x. They're asking for points of intersection. Okay. So what I want you to do is, here they're saying where f of x is equal to g of x. I want you to take your equation for f of x and equates to your equation for g of x. Now you're going to need your equation with the whatever q value it is. Now, okay, I'm going to make one up. Now, this is not the actual q. I don't know if it is or it's not. Ooh, that was terrible. I don't know if this is the answer or not, but let's just say it's this name. Now, can you see in this equation, I now only have one unknown, which is x, and I can solve for x very easily. I can say 4 over x is equal to x plus 3, and then I take over the 2, it becomes minus 2, so I now have minus 2. 4 over x is equal to x plus 1, and then 4 is equal to x times x plus 1. Do you see that I took this over and multiplied by this? Then blah, 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 blah. Then you can solve. Okay. Then I asked, they said they wanted a point of intersection. A point is what? It's a coordinate. Point, another word for point. In fact, we use that word point in place of what you guys learned previously, which is coordinates or ordered pair or whatever. Okay, so when I say points, you guys should understand that I'm implying that has an x value and a y value. So if you're looking for a point, you can't only solve for x and be like, that's the point. No, you need to also find the y value. Okay, and remember I told you that if you have an x value and you have the equation of the function, you can take the x value, plug it into the equation, and solve for the y value. Okay, if there are two x values, which you're going to get here because it's a quadratic function. Am I lying? Yeah, this is quadratic. Sorry, this is quadratic though, ne? Can you see if I multiply here and here, I'm going to get x squared plus x. It's quadratic. That means I'm going to end up with two x values. That means I need to have how many? Two y values. I hope I'm making sense. I hope I'm speaking English and not Greek. Ane? Alright, moving on swiftly. That was an example, by the way. That's not the actual answer. I don't even know what the actual answer is because the memo hasn't been released as yet. Honey? Then is g of x an increasing or a decreasing function, and motivate your answer. It's a straight line. Increasing looks like this, decreasing looks like this. That means this one has got a positive gradient. This one has got a negative gradient. Okay. But also now you should by the time you reach this question, you should have already sketched the functions. So you must know if the graph is increasing or decreasing. Okay. H of x is obtained by reflecting f of x over the x-axis and translating it down by 2 units. That's not bad. I told you how to reflect over the x-axis. What happens? If you don't remember, rewind and listen to what I said. And then translating it down by 2 units, that's also fairly simple, okay? Write down the domain and range of g of x. Oh, please, we did this 150 million times. So please go back and look at your notes, guys. Okay. I don't imagine that you guys have any questions after that lengthy explanation. But if you do still have questions, please just feel free to shoot your questions at me and I will do my best to answer timelessly. Please, guys, this should be handed in by Monday. I wanted Monday at the end of the day. Okay, please. There's no reason for you not to have it finished by Monday. Okay. Cool.